Problem 8. How many consecutive zeros are in the 20 factorial? Starting from the unit digits. So for example, the number 123,000 has 3 consecutive zeros starting from the unit digits. Okay. So we have 20 factorial equals to 20 multiplied by 19 times 18 times 17, 16, 15, 14, 13, 12, 11, and times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so we need to figure out, so how many consecutive zeros starting from the unit digits. Okay, so as we know, if we have factor of 5, so obvious, we know this one. Okay, so okay, we know 10 will give us 1 0, right? And the 20 also will give us 1 0. And 5, if we have factor of 5, so 5, because 5 times 2 can give us a 1 0. And the 15 times any 2 from 14 or from 8, 4 will give us 1 0. So then 5, 10, 15, 20. So these will give us 4 zeros, okay? 4 zeros. Okay, so answer is C then. So let's think about this. So actually we find out if how many factors of 5? 5 factors we have. Okay, how many 5 factors? Okay, so these 5 factors, because they do have 5, so we just need to multiply by 2, then we will get the 0. And if we have 5 factors like in the 10, so we even don't need to multiply by 2. So we just need to count how many 5 factors in the product. Then we would know how many consecutive zeros from unit digit. Okay, so here we have 4 5 factors, so then we have 4 zeros, right? Because each 5 factor we can have 1 0. Okay. Question 9. In the picture, there is a special dice. Numbers on the opposite faces always make the same sound. The numbers that we cannot see in the picture are all prime numbers. So which number is opposite to 14? Okay, so we have 14 plus a number which is prime, 18 plus the opposite face number, which is also prime, and 35 plus a prime number. So these are all equals to same number, same sum, okay? Okay, so let's look at these 3 numbers. So this is even, okay? So we know prime only has one even number, which is 2, and all others are odd numbers. So then we have a prime, so 3 primes, so at most 1 even, okay? So let's say we have 3 odd numbers, okay? If we have odd, and we know this is even, odd. So this one will give us the sum, which is odd, right? Even plus odd is odd. Then even plus odd is odd too. But 35 odd plus another odd number would give us even number. So that won't be the same sum. So that's impossible. So because we only have one even number, so we have to change the 35, this prime, to an even number. Okay, so an even prime, so only 2, right? Here, only 2, okay, can fit the description. Okay, so then we have 35 plus 2, so the sum 37. So then we can figure out 37 subtract the 14 equals 23. So the number is opposite to 14 is 23, which answer is E. Problem 10, x is a number that satisfies the equations here. So what is the remainder of x when it is divided by 5? So we just need to solve for x, okay? So we have equation x squared minus 2x equals to x squared plus x minus 120. Because we have x squared of the both sides of the equation, so we can just subtract it. Okay. So then we have negative 2x equals x minus 120. So then we can add 2x at both sides. So then becomes 0. This one, negative 2x plus 2x is 0 equals to 0. So 3x minus 120. So we plus 120 plus 120. So this is 120 equals 3x. So then we divide by 3. So we got is 40 equals x. So x equals to 40. So when 40 divided by 5, so we have 8. X divided by 5 is 40 divided by 5, remained 0. So the remainder is 0, which is A. Problem 11, how many triangles in the following figure? Okay, so let's look at the figure. So triangles would be like this, like that, right? So they all share this vertex here, right? So, okay, so let's count this layer, okay? So we have a triangle vertex. So then we would have, this is 1, this is a 2, 3, and we can have this one with these 2, 4, or 5, or we have the big one, these 2, right? 6, so total is 6. Okay, so let's look at this layer. Actually, we also would have 6 because they have the same layout, just larger. Okay, so for that layer is also 6. So total we will have 6 times 3, 18. So which is E. Problem 12, Alex, Bob, and Carl go for a walk every day. If Alex doesn't wear a hat, then Bob wears a hat. If Bob doesn't wear a hat, then Carl wears a hat. So today, Bob is not wearing a hat. So who is wearing a hat? So, okay, let's write down those informations. So if Alex, so the first one is Alex. Okay, no hat. No hat. So then Bob, actually, Bob will wear a hat. So the second condition is Bob doesn't wear a hat. Bob, no hat. So Carl wears a hat. So, okay, so then we have Bob today is not no hat. So who is wearing hat? Of course, from 2, we know Carl has a hat. right? Bob no hat, Carl has a hat. So if Bob no hat, actually, okay, let's look at the number one. So if Bob no hat, right? So can we know actually Alex wear a hat? Okay, let's think about it. So if Bob has no hat, so Alex has to have a hat. Why? Because if Alex has no hat, Bob has to have a hat. So Bob no hat means what? Means Alex wears a hat. So, okay, so from number one, so Alex had to have a hat. Okay, so I wanted to talk about this a little bit. So actually this called, if we have P, then we have Q. Okay, so this logic's contrapositive of this condition is no Q, then no P. Contrapositive is also true. If that's true, okay, the logic is true. The contrapositive logic is also true. So what is a contrapositive? Is this. So no Q, actually then you can know there's no P. Problem 13, which of the following figure cannot be the net of a pyramid? So what is the net? The net is a two-dimensional figure when you unfold a pyramid. So we look at these nets, we can know this pyramid with a square as a base. Okay, so I draw this pyramid here in 3D. Okay, so let's just check which one actually cannot be the net of this pyramid. So for the A, very easy to see, so we can fold this into a pyramid, 3D. And the B also could, right? But the C, if we folded these, so we have these two triangles overlap to each other, and we don't miss one piece here. So this side would be open, the pyramid, like an open door. So C is not. And we check DE. Actually, they are all could be the net of the pyramid. So the C is the answer, cannot be the net of the pyramid. Okay, problem 14. Cut four corners of a square of side length 5 as follows. So what is the parameter of the remaining parts? So the shaded one. So basically we have this figure, remaining part. So we need to find out the parameter. Okay, so it seems we need to find out the length of this length and that length and add all these lengths, right? But after we take another look at this figure, actually we can find out this length is same as this, okay? And that length is same as here. So also same, right? So these two lengths actually is just equal to these two lengths, right? Also this one. So the parameter of the remaining parts, the parameter is the same as the square. So we know the side length of the square is 5. So parameter equals 20. It's the E.